Welcome to Chapter 11, Analysis of Variance, or ANOVA, as it's normally called. We're definitely going to be using Excel in this chapter because the math behind this calculations are really rather advanced and long and tedious and fraught with errors if you try to do the calculations manually as we used to have to do it. And we're going to do some tests for differences among the means of several groups. So in this particular case, this is very much building on what we did before. I said the math gets really rather advanced, but we don't have to worry about that because Excel has this built in. So in this particular case, here's an example. We are going to compare like the accidents between the first, second, and third shifts, or expected mileage of the 5 brands of tires, things along this line. We have an assumption that populations are normally distributed, populations have equal variances, and the samples are random and independent from each other. All stuff that we've taken before. So what we're testing in the past is, or in this case, is the mean for the first population, the second population, the third, on and on, whether they're equal or not. So that it just expands what we were doing before. So HO is always that they're equal, so there's no variation, they're the same, or close enough that they're considered to be the same, and of course close enough we can statistically calculate. And H1, the alternative hypothesis, is the populations are not equal, and at least one of them is different. So in this particular case, you can see all the means are the same. So there's no factor effect. You get the same averages no matter what. And again, this just shows whether they're the same or they're unequal. So you can see the bottom left, 2 of the means are the same, but the third one is unequal. All we're testing for is to see if at least one of the means are not equal, and in the bottom right, all 3 means are not equal. So we have 2 types of variation. We have obviously the total of the 2. We have the sum of the squares among the groups, and then we have the sum of the squares within the groups. And so the total variation is simply SSA plus SSW. So you have among the groups is variation among the factor samples, and within the group that explains the data values within a particular level. Bottom line is, again, the software is going to calculate SSA and SSW, and it will tell you how much each one is influencing the total variation. So you have the variation due to the factor and the variation due to randomness, unexplained. So maybe that makes it easier to understand. So variation due to the factor, which is SSA, which is the explained variation, and the one on the bottom right, SSW, is the unexplained. So we don't know what's causing the variation. Here's again the formula, but we're going to use Excel to do this. We're just going to select the data and ask it to calculate an ANOVA table. And you can see that this uses something called an F statistic. The distribution actually looks quite a bit like a Poisson distribution. It rises and then has a long right tail. So it's not normally distributed. And the rejection region could be on the left or could be on the right. But once again, we're going to use p-values to determine that. So you want to see if the 3 different golf clubs yield different distances. And we have an automated machine, so that's standardized. And you can see that we have 5 different lengths that the machine has, or a sample size of 5 for club 1, 2, and 3. And we want to see which one if they have longer. Now, if you just look at the numbers, you can see that it looks like, just by the numbers, that Club 1 has longer driving distance than Club 2, and Club 2 has longer driving distance than Club 3. But if you know what you're doing, which we do because we're doing statistics, we can't just say, oh, it looks like Club 1 is longer. Is that just fluke? Is that just this 5? Or is that like 95% sure? So we're going to test it at a 5% level of significance, and which means we're going to have a 95% confidence. And you can see from this, yes, the formulas are not very pleasant to do the calculation. But what we have here, again, Excel will do all of these calculations for us. We just have to select the data and make sure we have it doing an ANOVA table for us. So you can, all of these calculations are just, the reason why I include it is just to show you the mathematical complexity behind it. With the technology we have, we don't have to worry about that. When I took statistics, we had to do all of these calculations. Yes, we had calculators, but we had to do all of these calculations. We were certainly not allowed spreadsheets in the classroom. And honestly, until a couple of years ago, Mount Royal didn't allow that either. And they didn't allow it, and the instructors didn't use it. But now, as of 2020, it's mandatory. We have to use Excel. And some instructors are doing it more, some instructors are doing it less. I'm going to try and do it to the higher end of that so that you're prepared for doing it in industry. So once again, you have the means are equal, the means are not equal. You have, again, you're trying to determine the p-value. It calculates the F statistic. And in this particular case, you can see that the rejection point is 3.89, which is called the critical value. The F statistic is 25.275, which is way to the right. So you're going to reject. But you can also look at the p-values on this. So the top one is the classical or the old way of doing things. The lighter shaded, which is the F statistic where the p-value is at least the 4 decimal places is 0, use the same logic that we did before in the previous chapter. So in this particular case, the conclusion is the same. You don't have to learn a totally new thing. You see all of these calculations. It gives us the sum, the average, the variance, and the totals between the groups and within the groups. And what you're looking for is cell F12. So what that means is you reject HO because the p-value is less than the level of significance. So you're rejecting the fact that the means are the same. And if the p-value is very low, then it means that the means are different. At least one of them is different. Doesn't know which one. If you take stats 2, they'll go into that. But you're looking for the p-value. P-value is less than the level of significance. You reject HO. And in this particular case, we're going to just, it's actually very simple with Excel. You select the data, select the ANOVA table, and away you go. And then you just need to know how to interpret it and read it. Even the last time I taught stats 2, what they do is they just provide you with an ANOVA table. And even in stats 1, we'll provide you with an ANOVA table, but you need to know how to create it. But then we'll also ask you certain questions where we'll give you the table and you need to interpret it. So be prepared for both.